You didn't get one? So today we're talking about properties of limits. Um, Properties are basically just telling you what kind of math rules can you apply to your limits, okay? And so we're going to look at what kind of math rules that we can apply. So the purpose of that is so that, well, if you know how to find the limit of this basic function, using properties, you can maybe start finding limits of more complex functions. And so that's the idea. Okay? So here's our properties that we're going to look at. I'm going to bring them up one at a time. It says let B and C be real numbers. So x is approaching some number C. Let n be a positive integer. So we don't have any n's up here yet, but we will. So B and C are just any numbers. N is an integer. F and G are functions. And then we have our limits of L and K. So let's go ahead and see what our properties are. So here's our first property. So if the limit of f of x is L, right, then the limit of f of x when it's being multiplied by b is b times L. Okay, that's it. So just like with derivatives and just like with integrals, if there's a constant, it kind of just chills there. It just sits there, right? When we took the derivative of 5x, the answer was just 5. Or in this case, when we take the limit of a function with a constant in front, it's just going to be the same limit, but with a constant being multiplied on it. Some are different. So if you want to take the limit of two functions that are being added or subtracted, that's just take the limit of both of them separately and add and subtract their limits together. Okay? Product, same thing. Now that's different, right? Because with derivatives you can't do that, and integrals. But with limits you can. If you have two functions that are being multiplied together, the limit of that would be the same thing as just taking those two limits and multiplying them together. Quotient, same thing. Limit of two functions being divided is just the division of their limits. Of course, k cannot equal 0, right? You can't divide by 0. And then we have the power rule, which is basically if you're taking the limit of a function to a power, that's the limit to the power. So it's basically just kind of like all the old math rules that we already know, and they're just basically letting us know that yes, it's safe. All those rules apply to limits too. Okay? So we're going to go ahead and put this to work for us here. Go ahead and find example 1 real quick. So we have two functions that we don't even know what they are. Okay, we know that there's a function called f, and we know that there's a function called g. And both of these functions we're having x approach c. Now, as x approaches c for the f function, we're approaching a y value of 2/5. So, and as x approaches c for the g function, the y value on that function is approaching 2. So we have two different limits here. And our job is going to be to figure out, well, what would these limits be over here then? Okay, well, does the constant affect anything? No, we said on our properties, basically the constant just sits there. So what is the limit of f of x as x approaches c? Just f of x. What is the limit of f of x as x approaches c? It was 2/5, right? The limit of f of x as x approaches c was 2/5. So we have a 5, and the rest of it we already know is 2/5. And so the final answer would be 2. Okay? So basically, just take the f of x limit and multiply it by 5, right? All right, number 2. The limit of g of x plus f of x. Well, what's the limit of g? And what's the limit of f? 2/5. And if you wanted to go through the trouble of getting a common denominator, be 5, 10, 12 fifths, you could. Okay? Number 3. using our multiplication property about limits. What's the limit? The limit of g is 2, right? Times the limit of f, which is 2/5. So the final answer would be yes, 4/5. Same thing here. It's going to be 2 over 2/5. Oh, good. So we remember from our talk about integrals that dividing by a fraction is the same thing as multiplying by the reciprocal. And so we end up with 5. Okay. Number 5. Limit of g is 2, right? And it's being squared. And so the answer is 4. So not too shabby, eh? So I just want you guys to get used to the properties and limits. I know that that's not horribly mind-blowing, but the point is that if you know the limit of a function, basically you can just find the limit like you normally would and just know that you can add, multiply, divide, and square, all that good stuff. Still applies. Okay, so why don't you guys give it a try. I put a couple up here for y'all. All right, so Trisha, what'd you get for the first one? What's that? 18. Okay, so basically it's going to be the limit of f, which is 4, and then we have 5, plus the limit of g, which is -1, times 2, and I agree, 18 sounds good. Number 2, Michael was burgled. Let's try Walter. Walter, what'd you get for 2? I agree. Just take your two limits and multiply them together. We'll skip 3. That's a repeat question. Mateo, what'd you get for 4? -1/4. Yeah, limit of g over the limit of f would be -1/4. Last one. Amanda, what'd you get for that? 1. Okay. So limit of g is -1. You square it, you get +1. So pretty chill. No biggie. Let's move on to something else. We're going to talk about doing the same thing. We're going to apply these properties, but with graphs a little bit. So let's see. Let me get out of this real quick. And I think if you guys look at your notes, let's see. We're going to move to the back page of your notes at this time. So go ahead and flip your paper over. All right. So we're on example 2 now. So let's go ahead and look at our first example here. The limit as x approaches 3 of f of x times g of x, right? Okay, now this time I'm going to show my work a little bit, but you don't have to when you're doing these, but I want to do it because graphs are a little bit less obvious what's going on sometimes with a graph. So once again, if you want to take the limit of 2 functions that are being multiplied, that's like taking the limit of each one separately, right? And multiplying that instead. And that's what we're going to do. We're going to take the limit of each of these separately and multiply the result. So we have a graph of f over here on the left. We have a graph of g on the right. What is the limit of f of x as x approaches 3? Yeah. Which one? It's -1, right? So here's me approaching 3, and the y value we're approaching there is -1. So there's that. And what's the limit of g of x as we approach 3? +1. That would be right here, right? And so my final answer for that first question on example 2 would be -1. Huh? Yeah, example 2, number 1 there. Yeah, let's go ahead and look at number 2. For number 2, we're finding the limit as x approaches -3 for f of x minus g of x. Okay. So what's the limit of f of x as x approaches -3? And what is the limit of g of x as x approaches -3? I would say it's right about there, 2. So we have -1 take away 2, which is -3. All right, last one, for example 2 anyway. We have the limit as x approaches 1 from the right for f of x over g of x. So we're just going to take the limit of the top as x approaches 1 and the limit of the bottom as x approaches 1. But both of those are going to be from the right. So what's the limit of f as I approach 1 from the right? It would be 0, right? Going this way and I'm approaching 0. And how about g? If I approach 1 from the right, what do I get there? There's 1. So we want to come at it from the right. It's approaching a y value of -1. And therefore the final answer would be 0. Now if the bottom was 0, that would be undefined, right? All right, so you guys do the second student practice set there. Give you guys a few seconds for that. Tell us what's up with the first one. Let me get the worksheet though so I can write the problem on the board. Oh. All right, so we have the limit as x approaches 0 of, is it 2 f of x plus 3 g of x. All right, so what we want to do is we want to find the limit of f first as x approaches 0. So what'd you get for that, Graydon? 2. So if I approach 0 from the left and right, it's approaching the same spot, which is 2. Good. And how about for g? 0 is also correct for that because we're approaching 0 from the left and from the right, and they're both approaching a y value of 0. And so it's 2 times 2 plus 3 times 0, which is 4 is our final answer there. Next one's interesting. Nicholas is not with us today. Matthew's with us though. So on number 2, we have the limit as x is approaching -1 for f of x times g of x. What do we get for that, Matt? Okay. You're right. So the limit for f of x doesn't exist. As I approach -1 from the right and left, they do not meet at a common point, so that limit does not exist. For g, as I approach 1 from the left and right, they do meet at a common point, and that common point is a y value of 1. But you can't multiply something that doesn't exist by something that does. Therefore, we would just say the final answer is does not exist. All right. Savannah, you're going to help me with the last one here. We're doing the limit as x approaches 2 from the left of f of x plus g of x. So what's the limit of f of x as x approaches 2 from the left? It is. So as I approach 2 from the left, I reach a y value of 1. And how about as I approach g of x, or approach 2 on the g function from the left? 2 from the left is 0. Good. And so our final answer would be just 1. All right. So that's applying the properties to graphs. Let's continue our slides here. I believe that I printed this for you as well, correct? Okay, so let's talk about this one a little bit. This one's kind of interesting. Composite functions. If f and g are functions, well, I don't really want to, such that the limit of g of x as x approaches c is L. So let's keep that in mind, okay? Keep that in mind. So we know that the limit of g as x approaches c is L, okay? And I'm asking you guys to find a limit of a composite function. Well, x is approaching c, right? So what function does that affect first? Does that affect the f function or the g? It's going to affect the g, because the g is the one that has the x, right? So as x approaches c, that basically means, well, what we want to find then is we want to find what's the limit of g as x approaches c. And whatever you get for that, since we're going to say that answer is L, that's kind of like you're just plugging L into the f function. Okay? Now, what I don't like about this is we're assuming that it's just a solid number you land at, but it may not be. I mean, we think of limits. So what I did on our worksheets, we're going to look at one-sided limits with these as well, and that kind of makes things a little more interesting. But for now, let's just go ahead and say when you're taking the limit of a composite function, all you're going to do is take the limit of the inside function, and whatever you get, that's basically what you're plugging into the outside function. So let's go ahead and do that on a graph real quick and see what that looks like. Okay, so for the first problem there in example 3, we have the limit as x approaches -2 of g of f of x, right? Okay, well, according to the little rule we just saw, if I want to take the limit of a composite function, since x is approaching 2, that's going to affect this function first. So as x approaches 2, then basically I want to be finding what is the limit of f as x approaches 2 first. So let's do that. What is the limit of f as x approaches -2? It's 0, right? So that means it's going to be g of 0. And what is g of 0? 0. There you go. That's it. Not too bad. So basically just take the limit of the inside function first, right? Let's take a look at the next one. Oh, just student practice. So you guys go ahead and try student practice 3. See what you get. Yeah, does not exist is correct. I forget the problem. It was the limit as x approaches 3 of g f of g of x. Good. So first of all, we're going to find the limit of the inside function first. And the limit of g of x as x approaches 3 is 1. F of 1 does not exist. There's no answer for that. At 1, we don't have a y value. Now, even if I put a solid dot here, even if I had a solid dot there, we still would have no answer. Now that could be confusing to you guys because we talked about this a few days ago. Isn't that just the y value? And isn't that the y value there? But here's the thing. This makes it look like, this is what I don't like about that little rule they have, so we're going to talk about how to deal with it. This makes it look like, hey, just what's the y value at 1? That's not quite true because really this is a limit. We're really approaching things. And so I'm wondering, even if there was a solid dot here, as x approaches 3, g is approaching 1, but from both sides. So if g is approaching 1 from both sides, then you're not really just finding the y value at 1. you're really approaching 1 and trying to find the y value. So it's kind of confusing. So what we're going to do now is we're going to look at one-sided limits to kind of flesh that out a little bit. Let's go ahead and do that. So let's take a look at, it's our last set. Number 1. The limit as x approaches 4 from the right of f of g of x. Okay, so let's do our first step, which is where we're going to do this. We're going to take our limit and we're going to plug it in here, right? You guys good? Now, let's look at our graph of g, and let's approach g, let's approach 4 on the g function from the right. So here's where x equals 4, and we're approaching it only from the right, correct? And where do I land? We land at 2. But really, we're not just at 2, we're approaching 2, right? True. Now, this number, doesn't this kind of act like an x value over here on this function now? Even though this is actually a y value for the g function, right? But over here on the f function, it's acting kind of like an x value, right? So as x is approaching 4 from the right, I'm approaching 2, but from which side? How do you know? It's not because of this, necessarily. You can't just say because we're approaching this from the right, we're approaching 2 from the right. And I'll show you a counterexample of that in a minute. Here's how you can tell. I'm approaching 2 from where? From, well, okay. Remember, these are y values, right? This is a y value. So I'm approaching 2 from what kind of y values? Not x values. From, it's not right and left, it's higher or lower, right? So let me rephrase that. As I approach x from the right, I'm approaching y equals 2 from above, right? Now, what do you guys think that would be, plus or minus? Above is plus. So I'm going to put a little plus there. That means I'm approaching the y value of 2 from above, right? Okay. So, but now, isn't that playing the role of an x over here? So if I'm approaching 2 from above, that's the same thing as approaching 2 from the right over here. Because it's a plus, right? It's above. Bigger numbers. All right. So I'm approaching 2 from the right. So here's 2. So what's my answer? The answer would be -1. Okay? But what I want you guys to understand is this means, for this function, I'm approaching y equals 2 from above. Okay? Now I'm going to show you, yes?
So would it be only with the slope, like the line of the slope is positive, or like?
Thank you. Good odds. You got, it has something to do with that slope, which way your line is going. And that's my counterexample. So you guys notice how this was plus, right? So you're thinking, oh, we're coming from the right. So this is always going to be plus. It won't, because if my line was sloping this way, where would I be coming from? From below, right? And that means on this graph, we're actually going to be coming from the left. Yeah.
Why isn't it does like this?
Well, when you have a one-sided limit, see, the reason why limits fail to exist is because the limit from the right and the left aren't matching. You say it doesn't exist. But if you're just coming from the right, you got an answer. It's just, it doesn't have to. So in other words, it's kind of like when you're a single guy versus you're dating somebody. If you're dating somebody, you better be in agreement. But if you're single, Kind of do what you want. Yeah, I could be 2. You be 1. I'd be 2, and we're good. But when you're married, this doesn't work. You can't have this. You got to meet. All right. So let's go ahead and look at the next one. Where was I? Okay. So the limit as x approaches -3 from the right of f of g of x. Okay, so once again, we're going to slide the limit onto the inside here. Now, I'm finding the limit of g as x approaches -3 from the right. So what is the answer to that? What number? If I approach -3 from the right, what is it? 2. Now, let's figure out what we're approaching from. If I'm approaching this from the right, from the right. Yeah, you're right. So we're approaching it from the right side. I'm coming at y equals 2 from above or below. From below, that means I'm coming from smaller numbers, right? So I'm going to put minus there. And that means in this case, I'm approaching the 2 from smaller numbers. Now over here, that 2 is playing not the role of a y anymore. Now over here, it's playing the role of an x. So if I'm approaching x equals 2 from smaller numbers, what direction am I coming from? The left. So do you guys see how these don't match this time? All right, so we're going to be approaching 2 from the left on this graph, which would be 1. So you get a different answer. So we had the same question written. No, we didn't. Never mind. Anyway, the answer is 1. All right, so that's the thing I want you guys to pay attention to, is that when you're doing a composite function, when you find the limit of this guy, you are approaching a y value from above or below. And then when you jump over here to your other graph, above corresponds to right, below corresponds to left. Okay? So, you guys try your student practices there, and that'll close us out for the day. I'll see if anybody has any questions. So for number 1, the answer was -1. And for 2, the answer was 2. Does anybody need to see one of these done?
Yes.
Which one?
Both.
Both of them. Okay. So let me get my work. -1 and 2 were the answers. You didn't get those. Uh-oh. Well, let's work it out. Here we go. So the limit, this is for number 1, the limit as x approaches -3 from the left of f of g of x. That is going to be f of the limit as x approaches -3 from the left of g of x. So the first thing we got to do is this. So first of all, let's get our number. What is the limit of g of x as x approaches -3 from the left? So it's 2. Okay, so I agree. But if we're approaching it from the left, then
that's the right.
Oh my gosh. I did that last time. This graph confuses me for some reason. So we're approaching -3 from the left. Now, if I'm approaching 3 from the left, I'm approaching the y value of 2 from above. So if I'm approaching 2 from above, I'm going to put what sign here? Plus, because it's coming from above. Now, over here, that 2 is now playing the role of an x. So above corresponds to what? It corresponds to right. So what we're doing then is we're approaching 2 from the right on the f function now. So here's 2. And from the right would be -1.
Why would it not be what? Now wait a minute. What about the one on top? On the
This thing?
Yeah. There's 2 of them.
But we're not approaching from both directions, are we? We're only approaching from the right. There's only one point we're reaching there.
If you're trying to get the other point, it's approaching from the left. But you're approaching from the right. So
I didn't even see that. That's why it does not exist.
Yeah, when you're doing one-sided limits, unless you're approaching an asymptote, you shouldn't get does not exist.
Stupid.
Well, I don't know about, what'd you call me?
Not you.
All right, let's do the last one here. Number 4, we have the limit as x approaches 3 from the left of f of g of x. So we have f of the limit as x approaches 3 from the left of g of x. So if I'm approaching 3, x equals 3, from the left, that's here, right? But I'm coming from the left. Now, if I'm coming from the left, my y value is approaching 1 from which way? From below. So that's like a negative, right? So I'm coming from numbers that are less than 1. Now, since that number plays the role of an x over here, because I'm plugging it into the f function, approaching numbers that are less than 1 would be the same thing as approaching from the left. So I'm approaching 1 from the left on the f function. So here's 1 from the left would be there. And so the answer is 2. Okay? These are these are one-sided limits. So there's a difference between a one-sided limit. They will exist at jump discontinuities. But the limit fails to exist. But a one-sided limit has an answer. Okay? So that's all I got for y'all. First of all, I don't think you'll see. I mean, this is a very specific application, and this is just me as a math teacher wanting to really explain something deeply. But I've never seen them do these kinds of problems on the exam, really. But I do want to point out, I don't know if this is technically good notation. Okay, they might accept that. I don't know. I'm not sure if that's acceptable. So. Yes. So I had this, right? Let's say I had this. We had x approaching -3 from the left of g of x, right? Well, we know the answer was 2, right? So what that means is that we're finding the limit now of the f function as x approaches 2 from the left. This would probably be the right way to write it instead of writing it like this, just so you guys know. Because I don't think this is proper limit notation, but I did it on purpose because if I did that, I'm pretty sure I would have lost about half of you. But now that we know the idea of what we're doing here, technically, this is what we're really trying to say. We're trying to find the limit of f as x approaches 2 from the left, and that's really the proper way to write it. But I wonder if they would actually give credit for that. I don't know. I feel like I've seen it somewhere, but I don't want to swear by it. So anyway, but we're just kind of splitting hairs here because, like I said, I've never seen questions like this on the AP exam. So, all right, so we're good.